Jagadish and Arija, to our two external guests today. So everyone else on the call is part of the challenge team. So thanks for coming. This is the launch of the RTDT Corrupted Measurements Challenge on We Do Wind. I'm Sarah Barber. I'm at the Eastern Switzerland University of Applied Sciences, and I'm responsible for this We Do Wind project. The idea today is to tell you first a little bit about what We Do Wind is, if you don't know, and also I'll tell you about the previous challenge we had in this space. And actually, RTDT is a Swiss company who Jan is going to then introduce you to after that. And then after that, I'll tell you about this challenge and what it's about. And Florian and Yuri will tell you about Renku, which is a data science platform that we're using, so you can participants can share what they're doing and make their code more reproducible. And then I've got a Mentimeter. I don't know whether it's worth doing it when there's only two attendees, but anyway, and then a Q&A part. So is that okay for everyone if we continue in that? Anyone got any questions? Okay, so yeah, I mean, We Do Wind is about trying to share. So it's about open innovation. The idea is that if people share ideas and data, then we accelerate the insights of the industry together. So that's kind of what we're trying to do on this platform. It was founded by my university, and we've actually founded a non-profit organization recently. And this slide is already wrong because we already now have more than 500 members. Here we have this board of directors team. You may know some of these people from different universities and companies who support the running of We Do Wind. And then we have an advisory board as well. Some of you might know these people. Yuri is on that list as well, who's here today. Yeah, and the general idea of We Do Wind is to we provide like these different communities for people to work together in. So in the information modeling community, we have all these different working groups where people can work on and align different information models or semantic artifacts. So for example, Yuri runs a group on trying to develop the wind energy domain ontology. We have a group looking at recommendations for sharing data and code. So recently we released some recommendations for publishing data. Then we have a community called a data users community, and that's kind of trying to just solve problems with using data like practically. So for example, we had a SCADA, we had a group looking at SCADA data, and they decided that the biggest problem at the moment was the SCADA alarms, trying to align the different names for SCADA alarms coming from different systems. And they then branched off actually into a new ontology group in this information modeling community. And the fourth community is a collaborative problem solving community where the idea is that we solve challenges, a bit like a hackathon, but it's all documented online. And the whole point of that is to say, okay, companies come with a certain question or problem, and we get different teams from the research community to solve the problem, but using the data belonging to the company. And so the idea is to kind of encourage companies to publish data. So recently we finished a challenge with Res. Res made some data available and ran a challenge. We have another company called Nadara who's just creating a new challenge with us. And we're trying to then get teams to take part to solve these challenges. We're currently experimenting with Renku, a data science platform, where we actually bring in the data and the code together and try to share more easily to make the code more usable after the challenge. And we're also working on an open data and code portal, which we're now calling the Knowledge Hub, where we are trying to catalog actually all existing wind energy code and data. And the idea is that then this these challenges are using this data and then actually updating or improving the code. We also have a jobs portal, which we're currently launching. And the idea, every time if you have people, you're going to have people looking for jobs. So one of the ideas is to get companies to post job descriptions on the platform and help us cover our costs of running the platform through that. And so who is it for? First of all, it's for asset owners. Asset owners usually own or have access to data. Sometimes they struggle to access state-of-the-art analytics, or they don't know how to publish open data, or they're trying to assess different methods from external providers. Then you have researchers who have the opposite. They've got the analytics, they're absolutely desperate for data, spend too much time with data wrangling. They might be looking for jobs or partners. They might also want to be looking to co-create information models. So the idea is you create kind of a win-win between them. Yeah, and then the recruiters, they're trying to attract talent. So what asset owners can do is they can run a challenge, they bring a problem, we try to get it solved, and we try to then offer them, improved innovation. The data scientists or researchers can participate or access data, or they can participate in a working group, for example, the ontology group I told you about before. There's also a student space, which Jagadish already presented at, I think, recently, where we're trying to bring students together. We also actually have a community lab where people can volunteer to do small tasks to support We Do Wind, and the job portal I already mentioned. And then recruiters, the main idea is that in the future they pay to publish jobs, and if there's lots of people on the platform, they might be interested in doing that. Yeah, and so the general idea is that these companies get more access to innovation and visibility, standardization as well. So we had an example with EDP. We actually ran a fault detection challenge with some of their data, and we had like 6 different solutions, and some of them were better than EDP's. So we could then, we applied like a cost model, so we could estimate how much money that they would have saved using the better model. And then RTDT is the company with whom we're working on this challenge. We already ran a challenge with them, which we'll tell you about in a minute. We did a challenge with RES. I'm actually currently writing a blog to document the results of that. And then we also work with Nuveen Infrastructure, who also have a space where we're working on your misalignment methods at the moment. And then to the previous challenge. So we had this challenge called the ASCE EMI Structural Health Monitoring for Wind Energy Challenge. It's the American Society of Civil Engineers group. And the idea was that we took data from a wind turbine, which was provided to us by ETH Zurich, and it was like structural health monitoring data, and there was some known events. So there was a pitch drive failure, there was aerodynamic imbalance, and there was an icing event. And the idea was to try to predict when these events would happen. And so you probably can't see this in detail, but we had like 5 different solutions, and it was quite detailed. Like each work itself was probably a paper. I think 2 of them have submitted separate papers where they actually applied a framework or a method that they actually already had. They applied it to this data, and then this allowed us to make some comparisons between the different methods. As I'm kind of showing here. That's just some pictures of what some of the methods look like. I can put the link in the chat later to the results. But for example, we could then use that to look at the strength of the weaknesses of the different methods. So we could say, okay, some of them are more accurate than the others, but some of them require quite a lot of supervision because they relied on features. Some of them were sensitive to outliers. And I think it was quite unique because usually you don't end up, because people apply different methods to different data sets, it's difficult to do a comparison. Yeah, and then we gave prizes. So the first place, we kind of had an evaluation panel where we actually analysed the results, and then we gave people like first, second, third place, and they got a certificate. They didn't get any other prize except for recognition and a certificate. Yeah, and then we've written a paper about it. The paper's currently under review in Wind Energy Science. Yeah, so any questions about that? So then I'll just pass over to Jan. I haven't got anything here, Jan. I thought maybe you just want to speak or show your own slides or do whatever you want to tell people who RTDT is.
Yeah, if I can share my screen.
Yeah, you should be able to do that. Yeah.
Okay. Can you see my screen now? Yeah.
Yeah.
Yeah, perfect. Thanks. So hi, everyone. I'm a machine learning engineer at RTDT, and I just will introduce shortly what's RTDT and what's our project. We are currently developing an industrial version of the AeroSense node, which is a flexible patch that is sticked on a wind turbine blade. And we measure kinematics, so IMU data and pressure-related or barometers data on the surface of the blade. It's wireless and solar-powered, so yeah, it's really easy to install on a blade. We have two types of products. So the first type is a package with 8 nodes to monitor one wind turbine blade, and we deliver the measurements, so the calibrated measurements of IMU and barometers. And the second one is the analysis engine. That's a set of modules where we can infer or compute some properties about kinematics, aerodynamics, and structural related properties. So for both of our products, it's really important to us to be able to identify anomalies or things that goes wrong, because when we measure data on a wind turbine blade, a lot of things can go wrong, either from the system point of view or simply at the sensor level. So it's really interesting to us to dig into this data and look what we can find. Thanks.
All right. Thank you. Yeah, for those of you who don't know, RTDT, this AeroSense product actually came from a project at my university. So we're always happy to see the progress of AeroSense. And now in this new challenge, we're actually using some data from this AeroSense sensor. And so what we thought is that we would look at corrupted measurements in general, because the motivation is that actually whatever you measure, right, you have problems with missing or corrupted data. So it could be wind measurement data, but it could also be structural health monitoring data or power, SCADA data, aerodynamic data, whatever. You're going to have, every time you have data, you're going to have some problem with some sort of missing or corrupted data. And corrupted basically means for us not just corrupted through a computer, but just data which has gone wrong somehow. So it could be the sensor's got ice on it, or the sensor's dirty. Maybe 2 out of 40 of the sensors have dropped out because they're broken, or they're something happened to them that we don't know about. And the trouble is, if you don't know if it's corrupted, it might be obvious if the value is just 0 or infinity or something, whereas there could be some cases where you don't know if they're actually corrupted or not. So trying to differentiate between corrupted and real data is important. So corruption can sometimes look like real physics. So maybe you can't differentiate between, is this actually, I don't know, the blade that's broken, or is it actually the sensor? that's leading to corrupted measurements. And so, yeah, it's kind of what I said before, different places corruption can come from. It could be an issue with the sensor, but it could also be the transmission, communication errors, but it could also be people making mistakes. Like somebody could put the wrong calibration coefficient in, or for a certain amount of time, or do something wrong in the measurement chain. So there is lots of work that's been done on fault detection, right? Also power curve testing and trying to find anomalous points, but it's not been done specifically to try to differentiate between corrupted data and like physics, things that have actually gone wrong. And so what I think, well, we think you can use these existing fault detection methods, all of which, by the way, are available in previous WeDoWin challenges. Lots of people have looked at that, but they haven't applied it to this idea of corrupted data. So can we use similar methods to identify different types of corruption, or to differentiate between corruption and fault on the wind turbine or not? That's what we don't know. And so I actually forgot to update this slide, now I noticed. So the goal of the challenge is to develop and compare methods for identifying corrupted measurements using a set of high-frequency rotor blade pressure measurement data from AeroSense. This picture's old because we've recreated the data on Zenodo, which we'll show you in a minute. But yeah, it's basically a set of aerodynamic measurements over a certain time. Well, we know there's been some corruption, right? If you look in the raw data, you can see it's not all perfect data. So we know something's gone wrong. The important thing to know is that we don't have a ground truth, right? We don't know when the measurements are actually corrupted or not. So what we're going to do in this challenge is we're going to get the participants to compare different methods, and we're just going to look at the results. So yeah, maybe if all the methods converge to one area of or time period, then you can kind of think that's okay. That's where the corruption really happened, or you can see how well the methods compare to each other. But what we don't have is a ground truth. So there's going to be we're not going to have like an RMSE or MAE value that we're going to compare, because we don't have that ground truth values. So what we're actually going to do is, what the participants are going to be asked to do is submit just a list of time periods for which corrupted measurements are identified. And optionally, you can classify that. So you can just submit 0, 0, and 1, but you could also submit different numbers to mean different types of corruption if you want. And the idea would be, this picture is showing, like on the x-axis, we have different measurement periods. So we would provide like 10-minute blocks of data, and then you have to basically submit. So this is on the y-axis, this is the different participant submissions. So participant number 0 says that it's corrupted here and here, and it's not corrupted here, and it is corrupted here. And then we can, if we have lots of different participants, we can compare this scale, for example. We can also compare like the percentage of corrupted data per participant. And so for each 10-minute block of data, we're referring to that like as a measurement session ID, and it's labeled. And then you can, for each of those, you can submit a 1 or a 0 or another number. And actually what we want to do is, like, up until the challenge deadline, you have to submit your results. But after that, we want to work on a combined model. So yeah, maybe the best parts of different people's submissions can be taken together in a combined model that's then outperforms the separate models. Yeah, so now I want to pass on to Florian to talk about Renku. So the idea of Renku is that, I mean, you can just download the data and use it, do it yourself locally, but we're providing Renku so that you can do it online in this platform. And the idea is that you can actually run code. We have some compute available, and the environment's pre-prepared, so it's already connected to the data. And there's already some code in there to access the data, and then you can develop your own code and then save it in there. And that actually makes it easier in the future for people to pick up from what you've done. Let's say we have a paper where where we're comparing the results, we can actually, in the paper, refer to this Renku folder, and then people can use it, they can run the code, they can develop it further if they want, or they can do comparisons more easily. If you have separate GitHub repositories, then it's often quite difficult to get them all working together. So we will, actually, it's not really true, we will have a notebook to read the data soon. It's not there this second. But yeah, as I said, so it's to try to make the results more accessible and reusable. And in the challenge description, there's instructions about how to do that. And so I think Florian is now going to do a demonstration of that.
Yes. Can you see already my screen? No.
Yeah, maybe I need to unshare mine first. Try again. Yeah, now it's working.
Oh, okay, perfect. So yeah, Renku is just it's a platform that puts everything together for you. That we provide a compute environment similar to Google Colab, if you know that. It has a pre-installed Python data science Jupyter environment, and the resources that you will have available for the challenge is 4 CPUs and 60 GB of memory and 20 GB of storage. And then what it allows you to add different data connectors. We added 3 already. The data that Sarah showed just now, which automatically pulls the data for this challenge already. So when you start your session, you have it there. You don't need to download it yourself. And we provided 2 more folders, a workspace folder with your participant ID folder, where you can permanently store your code that you're currently working on. And submissions is for the whole submission process. As soon as you have a CSV file for submission, you would save this in there. How this will look, you will see later. And then when you develop code, you don't need to necessarily use your workspace folder. You can also add your own GitHub repository, develop locally, develop in the session via GitHub. You would just click and provide the link to your GitHub. The idea later is actually that when you develop some code and you want to share that with a colleague, you would add your GitHub repository, you would add a link to your environment, and that person would be able to start a session and have your code and all the data already there, including the compute. So they wouldn't need to set anything up. They can just run your example if you did some analysis or some modeling. So that's a huge advantage when using Renku. You can really easily share your work with others. You would launch a session here, and this would look like on my next screen. 1 second. So when you launch a session, you will be greeted with this classic Jupyter notebook environment that you might know already. And now here we see the already mounted folders from the data connectors. The Aventa one, where we have the data, you double click in it. You have the submissions folder here, and you have the workspace folder here with where you can work in your respective participant folder. You can just create your notebooks, you can start a console, a terminal, and then keep on working. And as far as I understood this, we will have a notebook already included that shows you how to load this data actually to get you started. And then once you worked on it, you created your CSV result file, you would just put it in the submission folder. We have a script that automatically scans, I think, every day or every week or something like this folder, passes the data, and then creates a leaderboard or a visualization, a dashboard based on these results, which you can then discuss about in the upcoming workshops. That's for a little overview. Are there any questions about Ranker specifically?
I guess you just have to start by creating an account and see what happens. But do we, Florian, I was actually going to ask something I noticed in the, what I'm going to say next is that the next step is to sign up on this, in this Excel sheet.
Exactly. So what you would have to do is, you sign up in the Excel sheet, and then we can give you a link to Ranku. If you have a GitHub account, you can log in to Ranku with your GitHub account. When you do that, you will get a member or a name slug, and that you should also add into your sign up table that Sarah will show you later. And with that, we can invite you to the compute resources that's specific for this challenge.
That's actually what I was going to ask you a question. Do we, at the moment, the process in the description is that they have to fill out that form themselves for the resources, so we don't actually have to do anything. Like,
okay.
They click on They click on that. There's a link to that form, and that goes directly to Renku. So we don't actually. That was my question was going to be. I think with the current process, we don't actually need their ID. We don't need their Renku ID for anything, because before in the other challenge we do to give them access to the folder. But this one, we don't actually need it, do we?
No, that's true. I wanted to add them to the namespace, but that's not necessary because everything is public. That's true. We will give you the link to this public template environment. And the only thing you would need to do is you just click here on the info button on copy project, and then you can create your own environment based on your owner. So this is, you will be given a slug name like this, and then you create it under your own username, this whole environment. And then we can see how many copies have been created, basically.
Why does it say there are no copies? Because I created one.
You created one?
Yeah. But maybe it's not visible. I didn't put you on it or something.
Let's see. Yeah, there's no one.
Maybe people need to check. I mean, it's all in the instructions in the challenge description. So it should be obvious.
Again,
so if
you
you
just get the whole Python Jupyter environment with compute resources plus all the data connected to this already with some workspace to work in, and with the submissions folder to submit your results. And then the possibility to add your own GitHub to this. So that's what Ranku gives you.
So I just clicked on that link in the challenge description, and it actually is taking me to the wrong place. I think that Florian, can you just check that? I think that link might be wrong. I can change it very quickly, but I think there's I think we need to quickly change that link to the template. Yeah. So the link's in the challenge description. I'm just changing it because I think I was linking to the ODE your template by accident. No, it's the same one as you've just put in the chat. But yeah, I think the best thing to do is if you want to get started is just follow the instructions. So there's quite a detailed instructions for using Renku, and you should, if you just follow what it says, it should work. So you create a Renku account, fill out the form to get extra resources, copy the template like Florian just said, and then you can modify the available resources so you actually get the resources. And then you launch the session like he showed you, and then you have the different workspaces where you can work from. So it's best thing to do is just to try.
Yes.
I saw Yeah. Yuri, do you want to say something about the data? Or do we want to say, or does anything else, do we need to say anything else? Do we need to say something about the submitting your results as well? Because you showed the Renku, how to use Renku, but I don't think, did you say anything about submitting?
Just that there's the submission folder, so it's also in the description. When you submit, you will have to create a CSV file with a specific name tied to your participant ID, and it needs a certain structure. It needs 2 columns called session ID and I think data quality, comma separated, and then you would just fill this out in a tabular format. There's an example also in the description on how that has to look like. And then, yeah, I think I mentioned already, when you're in your session, you would just copy your file or your results file into the submissions folder. And then our script passes that and creates a dashboard based on your file or files.
And then it creates that leaderboard that we showed you. Okay, Yuri, do you want to say something about the data?
Currently, the Zenodo links to it links to the data source. It links to the correct Zenodo page, but I will be updating the data format and adding some metadata to it, so you will have actually like it will look a little bit different because right now it's not split by sessions yet. It's an old record, but within this week, probably the next couple of days, it's going to be updated. But that links to the most recent version, so it should be fine.
Yeah. Okay, Arijit, you wanted to ask something?
Yeah, I have a particular question to ask. Is this challenge also deals with data imputation in case there are missing data in the logs? Like that's a real challenge when it comes to wind lidar data, for example.
Good question. We did talk about doing that, didn't we, Florian? Because Florian's just finishing a project where he's looking at data imputation. We decided not to do that yet as a first step, but first to identify it. But I think having an imputation method would be a logical next step. I think if the participants are interested in continuing to do that, we can easily do that.
I mean, yeah, it's important, right, to first find out what kind of missingness you have. If it's missing at random, not at random, and based on that, you then can choose the right model, right? And this is the goal of this, to figure out what corrupted patterns do we actually have.
I can already say that most of corruptions we expect would be something that changes the accuracy of a sensor. So you would have some signal and it would move, like without changing its precision, but it would just like move, like drift. So there would be like instantaneous drifts, long-term drifts. And from what I saw a little bit from the data, just by visually inspecting it, there were also sometimes cases where something was going on wrong with the sensor and it would scale incorrect data. And if there is some noise that would pop up randomly, there are also time periods when the sensor would work intermittently, which would start introducing like a random noise. But it's quite easy. The noise that it was introducing was not like a specifically complicated pattern to see or to notice. but maybe for those, yeah, data imputation would be useful for those type of failures. But at the first pass, it will be already good to like identify them and just say, oh, these are all just sensors throwing random numbers that are not correct. Just take them out.
I mean, I think classifying them would be helpful from that point of view as well. Like from what it sounds like, Yuri, it would be the things you talked about had very different characteristics. And I guess it would be possible to somehow differentiate between the different corruption types.
Yeah, I would expect some kind of classifier algorithms to cluster that.
Okay, so basically the conclusion is if you want to participate, you can read the description, which is, I guess you already saw on Reader Wind. It's got quite a lot of details about how to submit and how to participate. But yeah, the first step is to fill out that table, which is linked to in there to participate, and then you have an ID, and then yeah, you can use the folder corresponding to your ID. And actually, the idea is that you sort of submit lots of versions of your results, a little bit like if you were doing a Kaggle challenge. I saw people doing Kaggle challenges like submit 100 times to try to fine-tune their results, their answer. We will be updating the leaderboard regularly, but if nobody participates, we're not going to be doing it like every hour or anything like that. So we're going to start with once a week, and if we see there's lots of activity, we can set our code to do it more often. Yeah, and then the idea is that we use the interim webinars to actually discuss methods that we've tried and try to have exchange ideas, and maybe then improve our methods by sharing and talking to each other about it. So the next webinar is on the 2nd of March. There's one on the 13th of April, and the final presentation is on the 25th of May. So yeah, I mean, that's it. Do you have any more questions, Arijit or Jagadish, about the whole thing or what to do next?
Yeah, it's quite interesting. I will explore the opportunities of this. The main challenge for me would be the how the coding and other things. So my experience mainly on the measurement side, but the corrupted measurement is a challenge in any operations. So it will be pretty much good for me to explore the possibilities and try to participate. I'll look into that. My experience mainly on the data collection side, and I have some of the concerns when it comes to data collection. The quality of data and corrupted information is always there. So yeah, it's a good space to explore.
I mean, one thing, I mean, I think you've got various ways you could contribute. I mean, the idea of Rinku is to make it easier. So I think once we've got the data reading code uploaded, we can let you know. But then you should, I mean, it might be, then it'll be quite easy for you to get started. You wouldn't have to install your own Python environment and all that stuff.
Yeah.
Or you wouldn't have to worry about trying to read the data, because we do it, and then hopefully the data would be then viewable to you, and it wouldn't be so difficult to analyze as it would be if you had to download it all yourself. So that's one way. And then the second thing is, yeah, just you could join forces with someone, or just come to the meetings and then contribute from your more practical point of view to a team as well. So that in the sign up page, we do actually have the option of where we ask the question, are you looking to join a team or not? And then we try to get people to work together. Like at the moment, we don't have very many people signed up. I mean, Arijit signed up, and you're here now, Jagadish. And apart from that, we haven't got anyone. And someone tells me that January is a bad time to try to do these sort of things. So we need to try to get a little bit more traction if we want some teams to take part anyway. But yeah, let's see. Maybe more people come to the next to the next one. Yes, you can't game it with hyperparameter optimization because you don't have the ground truth. That is true, Yuri.
It would be interesting, as I previously worked on this data imputation techniques to counter missing data issues in lighter data sets, but it'd be interesting to serve such corrupted data. Interesting.
Yes, well, hopefully. Yeah, I mean, if you want to start to try to use Renku, and then if you've got the best way to communicate with us is on We Do Wind, actually. So if you try to do something and got any questions, you can either write me a personal message up here, like you can write personal messages up here on We Do Wind, or you can it's actually better if you write a message on the platform, so you can. I know you can't write a comment here. There's a discussion. Actually, there's not a discussion. Oh, in the feed. So if you write in the feed here, everyone in the space gets a notification. So if you write in the feed, you've got any questions about it, I'll respond. So feel free to do that at any time. Okay, then we'll stop. Thanks for the introduction to RTDT, Jan, and yeah, hopefully once we start looking at the data, we can maybe some questions will come up as well for RTDT about how they deal with their data, or what different corruptions you've seen in your experience as well. So hopefully we can get an interactive discussion started about this, but let's see.
Sounds good.
All right, then see you all soon. Thanks for coming.
Thank you.
Bye.
Thank you. Bye.
Bye.
Thank you. Bye.